Procedures, functions, and triggers. In this nugget, we'll talk about the pieces of code, the pieces of PL SQL code that get things done for you. If you have something that needs to occur over and over again, it's better just to place that in a procedure or a function and reuse it over and over so you don't have to reinvent the wheel. So I lump procedures and functions together because syntactically they're very closely related. Really the only difference is that functions return a value whereas procedures don't. Now, when I say that these are stored pieces of code, what this means is we can find out information about them in the data dictionary. And if we want to make modifications to the code, we can do that. Now, oftentimes the end user of these procedures and functions don't know how things get done. In other words, all they see is the name of the procedure or the function, what types of parameters might go into it, and what type of data comes out of it. It's kind of like going to the bank ATM. This morning I stopped by the ATM and I just plugged in my username and PIN code and it came back saying, hey, you've got this much in your bank account. I can also go in there and say, hey, here's my username and PIN, and it can give me money back. So in that case, it would be a function. It's returning something to me. So I'll show you different ways of passing information or passing parameters into these procedures and functions. And there's three different types of notation that we use. Notation is just the order in which we pass information into our procedure or function. So we've got named, positional, and a mixture of the two called mixed notation. Then I'll show you how to hide your code with this thing called wrapping. If you've got some proprietary code, you might not want your end user to see how things are getting done. So you can basically do one-way encryption. And then we'll manage our procedures and functions. I'll show you data dictionary views, and then I'll show you also how to drop these procedures and functions. And then the second thing we'll talk about are triggers. A trigger is also a PL SQL chunk of code that is stored in the data dictionary, but it's different from procedures and functions in that you never directly call these triggers. A trigger is going to react to some event in the database, and when you define the trigger, you define when it's going to react. For example, you can have a table trigger saying, you know what, every time I update my employee table, I want to track all the changes in a log table somewhere, and the end user doesn't know what you're doing behind the scenes. For our table triggers, we can define our trigger code to be invoked every time the triggering action happens, or just once, even if that triggering action happens, a million times. Back to my example from the previous nugget, every time my daughter gets into the cookie jar, well, I can set up a mousetrap, and that the triggering action is her getting into the cookie jar. The reaction, the triggering code, can be the mousetrap going off. Well, instead of using the mousetrap, I can just give her one timeout at the end of the day saying, you know what, you got into the cookie jar 5 times today, but I'm just going to react once. We also have DDL triggers. Remember, DDL stands for Data Definition Language. So anytime we're modifying any objects in our database, for example, if you're dropping tables, altering tables, creating indexes, anything like that, we can track all of those changes. So it's kind of like a way of having a change control system within your database. So we also have log on and log off triggers, which enable us to track when people are logging on and off. And you can collect information such as, who the username was, the operating system user, what time they logged on, what time they logged off, what terminal they did this from. So if somebody claims that they had nothing to do with the database at a certain time, well, you can really check to see if that's true. And then the last thing I'll show you is how to enable and disable your triggers. How to do that individually, and also if you've got several triggers set up on one table, how to disable and enable them all at the same time. So let's talk about creating our procedures and functions. Imagine that you have a chunk of code that needs to be executed over and over on a regular basis. For example, in your HR schema, you've got a table called employees. And let's say you want to find out what the sum of the salaries are for a particular department over and over again, plugging in a different department number. You might have a web application that calls this. Maybe the end user types in the department number and it gives back the information. So if this is the case, you want to create a procedure or a function. Now, like I said, these two entities are actually so closely related that within the data dictionary, they're stored inside of the same data dictionary tables. The main difference is that a function actually returns a value. It contains a return statement, and you can call a function from a SQL statement, whereas a procedure is getting things done behind the scenes. For example, you might have a procedure that takes some input and then writes that input to a file somewhere. So down here in blue, we have the create or replace statement followed by either procedure or function. Now everything in curly braces is required. The pipe just means or. Anything in square brackets means it's optional. Okay, so after you say either procedure or function, then you've got your name, and then you can optionally have some parameters that you're passing in. If you've got a function, then you need to have the return keyword, and then you have to say what type of data you're returning. It might be a number, date, varchar, and then after that, I like to use the keyword as. Technically, you can get away with saying is as well. And then if you have any variables you need to declare, that would go here. So notice that we don't have a declare keyword anywhere in here. Instead of saying declare, we use as or is. Then we have our begin keyword, and between begin and an optional exception is where you have your main code, and then of course between exception and end is where all your exception handling goes. For your end keyword, you can simply say end, or you can say end and then the procedure or function name. I'm going to step you through an example of creating a function in our HR schema that's just going to take in a department name, and it's going to return the sum of the salaries for that department. Now this is going to be in the HR schema, so I'll log in as HR, and I'll just do a quick describe on the employees table just to familiarize ourselves with this. Okay, so you'll see that there's the salary column and there's the department ID column. Let's just take a look at what data is in there. I'm going to do a little formatting here to make our Outlook a little prettier. Set my page size to 999 just so we don't have pagination every 10 rows. Okay, so we can say select department ID and the sum of the salary from employees. Now remember that this sum is an aggregate function, so we need to have a group by clause on the department ID. So we say group by department ID, and there we go. Now to create our function, we're going to say create or replace, and then the keyword function, and then the function name. Let's call it sum sals. Now we want our function to take in a piece of data. We want it to take in the department ID number. So here we can have a variable. We can call it anything we want. I'm going to call mine D. Now you can hard code in the data type. For example, you can just say number, or you can use one of those anchored data types like I showed you in the previous nugget. So you say employees dot department ID percent type. Now the reason why we're creating a function here and not a procedure is because we want to be able to call this function from a SQL statement. You can't do that with procedures. So then we say what type of data we will be returning. So we'll say return number. If you are going to hard code in the data types, for example number or varchar2 or whatever, you cannot put any qualifier in parentheses. For example, you can't say number parentheses 4, or you can't say varchar2 parentheses 30. You just be real general about it and you say, I'm returning a number, I'm returning varchar2, and so on. Then we have our as or is keyword, and then we get down to the meat of what we're trying to accomplish. I want to declare a variable that's going to hold the total of a particular department ID. So this is where we do it. Between the as and the begin keyword, we declare our variables. So I'll just say total is of type number. And then we get to the meat of our program. So remember our select into statement. We can say select sum of the salary into total from employees where department ID is equal to, and that's where we can pass in this D. We can use the D in our statement. So that statement's going to populate our variable called total, and after that you must have somewhere in the body a return statement returning that number. Now as far as exception handling, well, one thing that can go wrong here is that there might not be a department number actually in existence that you passed in. So if that's the case, then this statement right here is just going to return no records, no data found. So in your exception handling block, so you can say when no data found, then, and have your handler. You might want to say, okay, I want to return 0. And then we say and our function name, and / to execute it. So our function has now been created. You might be producing code that's supposed to be ported to a third party. You want them to have the functionality of the code, but you don't want to let them see the actual code behind it. So to encrypt your code, you wrap it. The wrap command is simply a command line utility that's in the Oracle Home bin directory. So since it's there, you can call it from anywhere, and you simply say wrap iname, which is the input file, equals, and the full path to your SQL script that creates the package or function or procedure. So here we could say addemp.sql, and you'll see that it created this addemp.plb file for us. So we'll talk more about wrapping code in our packages nugget. So now to call this function from a SQL statement is quite easy. You say select and then the function name, and let's pass in our parameter. Let's pass in department number 50. And remember, we're not really querying from a real table here, so we'll query from dual. Your select statement always has to be querying from some table, so that's our dummy table. Okay, so we've got some output. If you want to take a peek into the data dictionary tables to see what your procedure, function, and package definitions look like, well, as a regular user, you're going to look at user underscore source. If you're the DBA, you'll be looking at DBA underscore source to see everything that everyone owns. So there's only 4 columns in here. There's the name of the procedure, function, or package, and then the type. So in our case, our type will be function. We've got the line number and the actual text. So let's query this. We're going to say select text from user source, where name equals, and make sure it's in all caps, and there it is. So we can scroll up and see the whole thing. Now, if someone ever asks you, hey, you need to modify a procedure or a function, this is where you would get the definition, and then you could just spool this to a file and make modifications, get rid of the text header, and then add the clause create or replace in front of the word function or procedure or package. In fact, we're going to do that right now. Let's spool to a file called s.sql, and then re-execute this statement, and then turn our spooling off. So now to put that spooled data into our buffer, we can say get s. That's fine if we get that error. The reason why we got the error is because we had this SQL prompt in there. That's fine. We're just trying to get it into the buffer. Okay, so this is where you would get rid of all this garbage up here and this garbage down here. And then you can add create or replace, and then your function name. One way we could modify this is to give our parameter a default value. So then we can call the function without passing in anything. For example, we can make 50 the default department number. The way we do that is we say default and then the value. So now I save it, and we can re-execute this, and our function was created again. Now let's call our function again. We can say select sum cells from dual. So whenever you're calling a function that doesn't have any parameters, or you're not passing in any parameters, that's how you do it. You just leave off the parentheses. Now if we had not had a default value for that parameter, then we would have gotten an error saying, hey, we did not call this function correctly. Okay, now let's do an example of a procedure. I want to create a procedure that will let us easily insert an employee record. So once again, we do a describe on our employees table. What I'd like to do is add a record in here without explicitly stating the employee ID. Well, there is a couple ways we can do that. We can either use a sequence, or we can select max ID plus 1 of our employees table and populate it there. Another thing I'd like to be able to do is say, you know what, if the department ID that we're entering doesn't exist in the corresponding departments table, we can go ahead and insert a record into there before we insert our employee record. So let's create or replace procedure and then our procedure name. Let's call it add emp. And then the parameters that we're passing in. Now remember, we don't have to bother passing in an employee ID. We want to make this easy on the end user. Okay, but we do want to pass in a first name, last name, anything that's not null in this describe here, we need to pass in. Okay, so I'm going to say first, and you can use your anchored data types if you'd like, or you can use hard-coded data types. For example, varchar 2. Now I'm doing hard-coded just to show you that if you are going to do this hard-coded, you cannot put parentheses afterwards saying what the max number of characters is. You cannot do that. You just have to be real general and just say it's varchar 2. Same thing with your numbers. You just say it's a number. Notice also that this word first here doesn't exactly match up here, and that's fine. We're going to be passing in parameters, and that variable first is just a placeholder. We pass in last, as well as our email and phone number, hire date, job ID, salary, maybe a commission, and a manager ID, and a department ID. And then our as keyword. Now we don't use the return clause because that's only used for functions. Procedures do not return values. In between the as and begin keywords, we have any variables we want to declare. So I'm going to declare EID for my employee ID. And I'm also going to declare a variable C that's going to hold the number of departments that have the particular department ID that I passed in. Okay, so I'll also make that a number. Now we can get into the meat of our program. So here I can say select max employee ID plus 1 into our EID from employees. Notice I terminated this with a semicolon. What that did is it populated the EID with the new number, and we know for sure that that number is not in use by any records in the employees table. You can also see if there are any departments with the particular department number that you passed in. Now I'm going to use an aggregate function. I'm going to select count just so we don't throw an exception. Okay, so here we'll say select count star into C from departments where department ID equals, and then we pass in this department right here. So if this count is less than 1, then we know that there aren't any records that meet that criteria. So we can have our if statement. If C is less than 1, then we're going to insert into departments. And we're going to populate the department ID as well as the department name, because the department name is actually a not null constraint. With the values of our department, and let's just put in here unknown, since we don't know what the name of the department is, but it cannot be null. And of course you always finish off your if with an end if. I'll make my window a little bigger. Okay, so now we're going to perform the insertion into our employees table. So insert into employees with the values of our employee ID that we set within our procedure, our first name. See how these parameters are just getting populated from up here. Okay, so we have our last, our email, phone, hired, job ID, salary, commission, manager, and department. And then we're finished with our procedure, so we'll say end. Or we could have said end add emp and then / to execute this. So our procedure was successfully created. You know, you can always do a describe on a procedure or a function. For example, you can say describe add emp. There we go. And it tells us whether or not there's already default values. So there are no default values here, which means we have to provide every single one of these values, even if it's an explicit null. The fastest way to call a procedure is with the execute command, or exec for short, and then you just say the procedure name. And then our list of parameters. So we pass in our first name, which is Julie, and then I'll pass in my last name, email, julie@abc.com. The phone number, I'll just leave that as a null. And then the hire date, I can say, well, I was hired 3 days ago. So sysdate minus 3. The job ID, we'll say IT Prague. And my salary, as well as commission, I'll just say I'm not commission based. And I don't want a manager either, so I'll say null. And then the department number. I can make something up here. For example, I can say department 88. There might not be one in existence. Well, since there isn't a department 88 yet, this procedure will create that department behind the scenes. So let's go ahead and execute this, and it was successful. So now we can select star from employees where, let's do a case insensitive search. So we'll say where lower last name equals Johnson and lower first name equals Julie. And there's our data. So it shows us that department ID of 88 is right here. We can say select star from departments, where department ID equals 88. And there's our department name. Right now it's unknown, but we could come along later and change that if we wanted to. Doing a describe again on our procedure, just want to show you how there are no default values here, which can be quite cumbersome. Let's say that you had a procedure or a function that took in maybe 30 parameters. You would have to provide a value for each and every one of them. But if you provide a default value, then you don't have to provide the value. It will actually default to that. So what I'd like to do now is modify a procedure a little to provide some default values. So the way we do that, we say select text from user source, where name equals add emp. And remember earlier we spooled it to a file and then modify the file. Another thing that we can do is copy and paste. For example, we can say create a replace procedure. Actually, we can just copy all of this in here to the end. We just recreated it. It's now in our buffer. Now hit ED to edit it. And let's give a default value for our first name. We'll say default null. Now we can't do that for the last name because that last name is a required field. Same thing with the email. We can give a default of null for the phone number. Hire date cannot be null, but we can provide a default and say sysdate -1. So whenever we call this procedure, it will mean yesterday this person was hired. Let's give a default for job ID. We'll say default IT underscore Prague. Let's not provide a default for the salary, but let's do provide one for the commission because not everyone is commissioned. Just to make things easier to read, I'll add some new lines. So notice that for the varchar data types, you're going to have your stuff in single quotes, whereas numerics does not have quotes. And then we'll go ahead and save and then execute again. And let's call this procedure one more time, this time with slightly different values. Now instead of using the exec command, we can actually call this procedure from within an anonymous block. In other words, we can have a begin statement and then call our procedure. Now the way I'm going to call it this time with the parameters is I'm going to use what we call named notation. In other words, I'm going to explicitly state what parameter is what that I'm passing in. For example, here we'll say that our last name, see we're explicitly saying that this parameter here is equal to Smith. Then we can say, well, the email is smith@aol.com. The salary is $75,000. The manager is null, and the department is 60. Terminate that with a semicolon, then you say end. Now notice that I didn't pass in all the parameters. The only parameters I had to pass in were the ones that did not contain default values. So since first name had a default, didn't have to pass that in. I could have passed all these parameters in whatever order I wanted to. Okay, so think of this equals greater than symbol to just be an assignment. This was actually taken from the Perl programming language, so if you're a Perl programmer, you should recognize this. And there's one more way we can pass in our parameters. We can use a mixture of positional and name notation. In other words, we can start off with positional. We could populate the first, last, email, phone, and then so on. And then somewhere in the middle, we can decide, you know what, use name notation. Kind of like this. We'll do begin, add emp, and then we'll say, for the first parameter, John, Jones. Okay, so far we're using positional parameters, and then we can go on and say, you know what, the email is john@xyz.com, and so on. So we'll provide a salary here, as well as a manager and a department. So once again, this is what we call mixed notation. What might be a mystery to you is what exactly the new employee ID number is for these two new records that we've inserted. The way we have our procedure defined right now, the only way we can really find that information out is by going into the employees table and querying those records. Another way we could do this, though, is we could redefine our procedure to include what we call out parameters. Out parameters are parameters that we pass into our procedure or function that are going to be assigned by the procedure or function. And then we can query what that variable is. So let's go ahead and redefine our procedure. We'll go ahead and just copy all this. Copy it. And then paste it. And we'll probably get an error because it looks like some of the wording got chopped off, and that's okay. It looks like default null, the word null got chopped off. So we'll just hit ED to edit this and put in the proper information. Okay, that looks a lot better. We're now going to add our new parameter. We'll call it EID, and we'll say that it is an out parameter, and then the data type. Now, the rule with out parameters is whatever you're passing in has to actually be a variable. You can't put a hard-coded value because remember, the whole purpose of an out parameter is for it to get assigned. Okay, now if we still get compilation errors, one of the things we can do is say show errors, and it will tell us what line the problem is on. Okay, so it's complaining how the EID was duplicated. In other words, we have an EID up here and we have an EID down there. We don't need this EID anymore down here because it's already being used up here. So we're going to do our select into EID, but it's that out parameter now. So let's go ahead and modify this one more time, get rid of that line, and try this again. Okay, so our procedure was correctly created. I'd like to now use this procedure. Let's create a bind variable. Remember the bind variable from our earlier nugget where we say var and then whatever variable we want to call it and then the data type. This is used within SQL Plus. So now we can use this when we call it. So we'll say begin, add emp. We pass in our E. We say :E. Let's provide a last name. We'll say Phillips. And an email, as well as a salary, manager, and a department. And we terminate this. Okay, so this is successfully completed. Now we can just simply print out our E. And so our ID of Phillips is now 210. So think of these out parameters as a way of peeking into values inside of your procedure or function. I usually use these in conjunction with bind variables. So far, the types of subprograms that we've covered have been procedures and functions. Now remember, there's another type of subprogram called a trigger, and that's just a piece of code, PL/SQL code, that reacts to some event in the database. That event might be some activity on a particular table, or it can be log on or log off activity. And more often than not, the end user is completely unaware that the trigger is getting invoked in the background. So that means that we would never call a trigger directly like we would with a procedure or a function. How about if you want to track the salary history of your employees? So what you want to do is create a trigger on your employees table, specifically the salary column, and whenever an update occurs on that table, you can then enter information into a log table. You can specify, who made the change, what the employee ID is of the person whose salary is changing, the old value, the new value, the timestamp of when it occurred. Okay, so before you would create that trigger, you'd have to have a log table to store all this information. So let's go ahead and do that. Let's create a log table. We'll call it salhist. So we'll say create table salhist, and we'll say we want the employee ID. We want the timestamp of when the change occurred. We want to know who made the change, as well as the old salary and the new salary. When you create your table trigger, you need to give a specification. Okay, so this is what the specification looks like. It just has some information regarding when the trigger will be invoked. Okay, so we just say create a replace trigger, give it a trigger name. This is going to be before or after. An example of an after trigger will be one where the trigger is invoked after a successful delete or insert or update. A before trigger would be a trigger that's invoked before an attempted delete, insert, or update. We'll do examples of each. The one that we're doing now is the after trigger because we don't want to insert records into our log table if it was an unsuccessful update. So for our particular example, our table name is going to be the employees table and the column in question is the salary column. The for each row clause means that this trigger will be invoked for every single record that's affected. For example, if I'm updating 1,000,000 records in my employees table, then I'll have 1,000,000 records inserted into my log table. If I leave this for each row clause off, then it makes it a statement level trigger. In other words, the trigger will be invoked only once, even if we have 1,000,000 updates. And then we have our body, the body code that gets invoked when this condition is true. Let's actually create the trigger. So we'll say create or replace trigger, and we give a trigger name. Let's call it saltrig. After update of salary on employees for each row. Okay, so now we can get into the meat of our program. So we'll say declare. If you're declaring any variables, it occurs between declare and begin. We have no variables to declare, so let's just jump right into our begin section. And what's really cool about triggers is that there are already some built-in bind variables in our triggers that store the before information and the after information of our rows. And that bind variable is called old and new, and we precede them by colons. For example, we can say insert into salhist with the values of, and we need to provide the employee ID. Well, what is the old employee ID? Well, it's the same as a new employee ID. So the way we access it, we can either say old or new here, is colon, old, dot, and then the column name of our employee ID. So that is employee ID. The timestamp at which this occurred is right now, which is sysdate. Remember, sysdate is a function that just returns the current date. Who is the person who's making the modification? Well, if we say user, that also is a function. It returns the current user. And then we grab the old salary, so we say colon old dot salary, and then we grab the new salary. And finish this off. Let's test this. How about we give everyone in our employees table a 5% raise? The way we do that is update employees. Set salary equals salary times 1.05. Now we can do a select star from salhist. Let's see what we've got. See all that information there? It did get modified. We've got the employee ID, the timestamp, who made the change, the old salary, and the new salary. I'll go ahead and grant the update privilege on my employees table to Scott. And now we're going to log in as Scott and make a couple modifications. Scott will go in there and lower everyone's salary. So he'll say update HR.employees set salary equals salary times 0.95. 110 rows updated. Let's connect back in as HR and look at our log table. Select star from Sal Hist. We have a lot more data in there. Do you see how Scott showed up here? Now the next example is a statement level before trigger. What I want to do is prevent any users from altering anything in the employees table after hours. So let's consider after hours to be before 6 a.m. and after 8 p.m. So if we're trying to update a million records, we just want this trigger to be invoked once. So we say create or replace trigger, and let's call this after hours. And this is a before, delete, or insert, or update on employees. And we leave off that for each row clause. We delve right into the body. We don't have any variables to declare, so we'll just get right into the begin section. And we can say, look, well, how do we grab our hours? Well, the way we can do that is use the toChar function, grab our sysdate. To grab just the hours portion of our sysdate, we use this date formatter. We can say HH for hours. 24 means military time. If that value is less than 6, or toChar of sysdate, HH24, is greater than, I said 8 p.m., so that would be 20, then we're going to do something. Well, we want to raise an error and not allow the modification to take place. So the way we can raise an error is we say raise application error. This raise application error takes two parameters. The first one is a number that we're going to associate with this error. And you can pick pretty much any number that's in the negative 20,000 range. For example, you can say negative 2999. The reason why we give a number is then if this is called from somewhere else, it can actually be caught by that particular number. And then we have in single quotes the string that we want to show the end user to let them know what went wrong. So we'll say cannot modify employees before 6 a.m. or after 8 p.m. And then we do our end if, and then our end. It happens to be after hours right now, so let's go ahead and test this. We'll do an update employees, set salary equals salary times 1.05. See our nice little error message? Another type of trigger we have is called a DDL trigger. It is the type of trigger that allows us to track what types of DDL activity has occurred. For example, if I want to keep a log of all the database objects that have been dropped, what time they were dropped, and who dropped it, sure, I can do that. In order to track that type of information, the user has to have the administer database trigger privilege. So I'm going to log in right now as a sysdba, and I'm going to grant that privilege to HR. So I'll say grant administer database trigger to HR. And now I'm going to log in as HR. Before we create our trigger, we want to create a log table that tracks all this information. So let's create a table, and we'll call it dropped objects. And we want to track the owner of the object, as well as the name of the object, who did the dropping, and the timestamp of when that drop occurred. The syntax for this DDL trigger is really similar to table triggers. We start off by saying create or replace trigger, and then the trigger name. Let's call it drop trig. And for our specification, we'll say after drop on database. The on clause just specifies whether we want to do this monitoring on the database level, or a regular user can say on schema if they just want to do tracking within their own schema. Okay, so now we get into the body section. We'll say declare. We don't have any variables to declare, so we'll just jump right into the begin section. And this is where we do our insert into our dropped objects table with the values of, well, we want to grab the owner. There's actually a built-in function called Oracle dictionary object owner. There's another function called Oracle dictionary object name, as well as the user who did the drop, and then the timestamp. So all four of these values here are built-in functions that are available to us. And now we can say end, and our trigger's been created. So now we can create a bogus table. Let's create a table called foo, a real simple table here, and now let's drop it. Drop table foo. And then we can query dropped objects. There's our information. The owner of the object was HR, the name of the object was foo, it was done by HR, and there's the timestamp. And we can make this formatting a little prettier. We can say set line size to be 130 and format column owner to be a little smaller. Try to fit everything on here. And then re-execute it. Let's create another trigger. This will be a logon trigger. We're tracking when people are logging onto the database. Once again, before we create the trigger, we need to create a table that holds the logging information. So I'm going to call my table logon log. And all I want to store is who was logging on, as well as what time. So we'll make that a date data type. And the host name that they were logging in from. So we'll just say host. We now create our trigger that's going to insert records into this log. So create or replace trigger, and then our trigger name. I'm going to call mine logon trig. Now this is an after logon on database. Once again, you have to have the administer database trigger to do this kind of trigger, and we've already been granted that, so we're good to go. And then if we want to declare any variables, it would appear between declare and begin. We don't in this case. We're just going to jump right into our insert statement. So insert into logon log with the values of, and so the who is going to be the user. Remember, that's a function. The time is going to be sysdate, which is also a function. Now, for the host, we can find out what the host name is from a function called syscontext. What this does is it can give us information about different environments. For example, one of the environments we can find out about is our user environment. So this is a built-in attribute. Okay, so one of the attributes of our user environment is the host from which the client was connecting. And we finish this off, and our trigger's been created. So now let's connect as someone else. Let's connect as Scott. And then we can connect back again as HR. And let's query our logon log table. Okay, so you'll see that this information has been logged in here. Now, if you want to see exactly what time this user logged on, you can always say alter session, set NLS date format, and all we're doing is changing the way our date appears within our session. So here we can say we want it to appear as month, month, day, day, year, 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 as well as military time, and MI means minutes. And then we can re-execute, select star from logon log, and you'll see the time. If you want to temporarily disable the trigger that you've created, you can always say alter trigger and then the trigger name. Logon trig, and you simply say disable. And the opposite of disabling a trigger is enable. So you just say alter trigger, logon trig, enable. You know, back to our example where we had the two triggers on the employee table. Let's say that we were bulk loading 1 million records into our employee table and we don't want to turn on those triggers. Well, you can turn off or disable all the triggers on a table all at once by saying alter table and then the table name followed by disable all triggers. And likewise, you can go back and change the disable to be enable back like it was. To permanently get rid of a trigger, you simply say drop trigger and then the trigger name. So that wraps up our portion on triggers. Let's review what we've learned in this nugget. We first of all covered procedures and functions, which are so closely related that they're actually in the same data dictionary view. There's in parameters and out parameters. Remember, out parameters are those that can be set by the function or procedure itself. Then I showed you 3 different types of notation. We had named notation, where you use the equals greater than symbol to do assignment. We have positional notation, and then a mixture of the two. Then I showed you how to hide code with wrapping. So if you need to hide your proprietary code, you use the command wrap. And remember, that's an OS level command. And then I showed you how to drop your procedures and functions, and that removes it from the data dictionary. Then for our triggers, we had 3 different types of triggers here. We had our table triggers, which react to different types of insert, update, and delete activity on a particular table. We had DDL triggers. Those are ones that react to data definition language statements such as drop, create, alter, grant. And then we had our logon triggers. So we can monitor when people are logging on or logging off. And then, of course, you can disable and enable your triggers as well as dropping them. Well, I hope this has been really informative for you, and I'd like to thank you for viewing.